Is it visible?
Yes, sir.
Okay. So what we'll do is in today's class, we will focus on some problems so that you will get confidence what we are studying exactly. And it may help you for your exams also. So, so what we have discussed, if you recall, in the last classes, one thing is pressure at rest, where K naught is. Once you know the K naught, we can find out the once you know vertical pressure and K naught, when you multiply, you will get the pressure at rest. Okay. So, and active earth pressure, passive earth pressure, Rankine's earth pressure theories, Coulomb's earth pressure theories. Their assumptions, Rankine has assumed vertical and smooth surface, and later on he has given for I mean inclined surface also, inclined this one wall also. Coulomb is assumed for rough surface, more general than the Rankine theory. And we have seen both Rankine and the Coulomb's theory. And the last classes, we have seen that for different soil, cohesive soil, C5 soil, I would say, or only friction soil, I mean sandy soil, how this earth pressure coefficient will vary. And we have also seen the tension crack, support height, unsupport height for a cohesive soil and so on. Okay, hope you have gone through it. If you have gone through it, okay, then these problems are very easy. So you need to read every day. So let us see this problem, what exactly this problem says. Visible, right? May I continue?
Yes, sir.
So determine the lateral earth pressure at rest per unit length of the wall shown in the figure. Okay. Also determine the location of earth pressure. Take K naught is equal to 1 minus sin phi and the gamma equal to 10 Newton per meter. So what is asked? It is asked to find out the, we have some retaining wall, lateral earth pressure at rest condition, that means wall is not moving at all. Okay. So, and it is also given the this one. So what is the solution here? First, what we do, we find out this K naught 1 minus sin phi. Phi we know. Okay. Phi should be given. Okay, it should be 30. Determine the length version of figure. Also determine the locations of the resultant earth pressure. Take K naught is equal. Okay, because they have forgot to mention, I think. Okay, 30. So here it is given, sorry, here, so this is what they have given. Okay, figure 9.1a. So this is 9.1a. Okay, now look at here, this is one type of soil and this is one more type of soil. Phi is 30, gamma is 17. Next layer of the soil is phi is 30 and gamma saturation is 19. Here water table is given, that's why it is given as the gamma saturation. Clear? That means a retaining wall is given, two layers of soil is given, two layers of soil with phi and gamma values are given. Wherever water table is there, gamma sat is given, and it is asked to find the pressure at rest conditions. For pressure at rest condition, what we need to do is we have to find first K naught, okay, for a first soil, because both soil K naught is same, I think. Okay, then in that case, anyway, I'll tell you how we have to do it. Then after finding the K naught, first find out the effective vertical stress. Two multiplied by gamma, nothing but be 34. Here there is no water table, u equals 0. Next is 2 multiplied by at a depth. Okay, first we will take the point B, or you can take A, B, C. 3 points are there. So each point we first what we have to do is first we find out the vertical stresses. Then we should multiply with the K naught. What is the vertical stress here? A 0. That's why they have not taken at the point A here. If you find some surcharge, then here if you have any surcharge, then there would be some pressure on the at the point A. So there is no surcharge, free surface. So A equals 0. Now let us take at the point B. Point B will have two layer, first layer soil. Point B is the first layer. Understand? Here 2 into 17 plus this one is 0, nothing but 34. What is the pressure at rest? We have to multiply by K naught. You will get 17. At B, at C, 2 into 17, first one, plus water table is given. Okay, gamma sat minus gamma dash, nothing but the 19 minus 10 multiplied by 2 is equal to 52. Then what we have to do, we have to multiply with that. That will give the effective stress or pressure at rest condition, P naught. We can draw the diagram also. Here, this is 1, 2, 3, 4. If you draw it, okay, figure shows the pressure distribution diagram has been divided into 4 parts, P1, P2 due to these parts. Okay, 1, 1, 2, 3, 4. What is 1? How much it should be generally? 17. Okay, 1 is 17 here. That it is mentioned here 17. 17. Next is how much it would be? 26. Both. That means this two should be 26. 17 plus 9. Then pore water pressure, that is 2 into 10. 20. This pore water pressure won't start from here. It will start from here only. Okay. That's all. Very, very simple. That's how we can, and we can get the force also. Okay. Now we are getting with unlimited pressure. Here, if you see, we can find out the force also. How we can find out all triangles, rectangles, everything is there. No, triangle half into base into height. Half base 17 into height 2. You will get 17. This is the rectangle 2 into 17. half into base into height, half into base into height. Okay, total is 80. The where it will act, let us take a line of action generally, because if it is single triangle, we can say that h by 3. Okay, since it is not the single triangle. Okay, so what we have to do is we have to take a moment about the C from here. Okay, so 17, this is 17, where it is acting first one. Okay, 2 place h by 3, 34, 1. Okay, half of this one, 1, this one, then here and here. It will act at the from the base 1.23 meter. What is h by 3 actually? 4 by 3, right? It would be very near to this one. 4 total height is 4 by 3. So what is 4 by 3? What is 4 by 3? How much you will get it if you multiply 4 by 3? 1.33. So here you will get 1.23. That's what how we have to find out this pressure. Understood? So next problem will go. So what it says next problem here, what we are doing is okay. Let me explain this one. So determine the active earth pressure is asked. Determine the active earth pressure on the retaining wall as shown in the figure. Okay, gamma unit weight of water is given. Unit weight of water is given 10. Sometimes if it is not given, you take 9.8. Okay, if it is given, then 10 you just take it. Whatever is given, you just take it. Otherwise, you should assume as at 9.8 only. So here this figure is given. Again, point A, point B, point C. 2 layers of soil with phi equal 35, phi equal to 38. And here again 17, 18, there is a water table here. So below that it is in a saturation condition. Understand? So now here what is happening is phi value is changing. In that case, what we have to do is this layer, we call it as an interface layer. Okay, when you calculate the earth pressure, we have to take it as upper layer, lower level. So in this interface, anyway, I'll tell you what it is exactly. Now, as it is mentioned as active earth pressure, we have our focus should be on K. Okay, what is value of Kp? Reverse of this one. So it is Ka is asked. That's why I'm writing. Kp is 1 plus sin phi by 1 minus sin phi. K is 1 minus sin phi by 1 plus sin phi. Understand? So Ka, Kp, once you know, and once you are able to find out the vertical stresses, you can easily find out the active earth pressure. So what is the next step? First step, what you have to do is we have to calculate the Ka values. If two Ks are soils are different, then calculate both upper layer and the bottom layer. This is bottom, this is upper layer. Okay, so these are the values. Ka, we got it. Now what we have to do is we have to find out the vertical stress. Vertical stress A is 0. A layer, I'm talking, what a whole layer. So A plane. At the B plane, what is the vertical stress here? For the vertical stress, 2.5 multiplied by gamma. Any pore water pressure? Nothing. 0. Then, so here, this is the, it should be multiplied with the Ka upper layer. Getting? You will get 11.5. Now, you just draw this pressure diagram, okay? 11.5. So draw this 11.5. So after drawing it, what we have to do is, we should not go directly to the layer C, because here at the layer B, where exactly because soil is changing, we don't know the interface exactly, okay, from which point it is. So because you may ask why we have not taken this one then, because soil is touching, no? When PA can be found as upper layer, at the interface, that is touching with the one more soil, okay? So in that case, what these people have done it, so why we should not take this one then, because it's touching it. In that case, what they have done is they have divided it into two phases, below interface and upper interface, okay? So here, whatever we have done is upper interface, then below interface, if you do it, then you calculate with this 0.28. This one. First we use this one, then use this one. Now when you use that one, it reduces to 10.1. First 11.5. Okay. Next 10.1. So this is active earth pressure, okay, which is acting like this. So then what is happening here after increasing, here decreasing? This is 10.1. 11.5 is above interface, the same plane only, and 10.1 is the below interface. Understood? 11.5 is just above the interface of that particular layer. 10.5 is just below that one. Okay. Then what you have to do is at the point C, anyway, there is no change in layer, only one cell we have here. At the point C, what you have to do? We have to find out the vertical stress. What is the vertical stress? 2.5 multiplied by gamma. Then 2.5 plus 2.5 multiplied by 18. But why 8 is given here? Can anyone answer?
So pore water pressure.
Exactly. Okay. That is directly given as 18 minus 10. Effective vertical stress only where, because dash it is given, right? So effective. Then you will get the 62. That means the whole thing will come as 62. Then what we have to do is this layer Ka we have to multiply with that. Okay. 62, this one multiply that, you will get 14. Then pore water pressure is 25. Understood? So what is happening here? Here, this is 2.517, 2.58, 62, 2.510. So here there is no water. So 2.5 into 10, it is given as 10, okay? 1025. Then this we have to multiply, right? This is the vertical stress. Then we have to find out the horizontal stress. This is the vertical only. To find out the horizontal stress, horizontal RPA, active earth pressure, we have to multiply here 0.2, because there is only one soil here. There is no interface here. No need to take interface here. Only we have to take interface here. Just above, just below you have to take. Just above, just below. Okay, here. Then if both phi's are equal, then you will not get. Why you are not taking in previous example? Because both phi's are same. Phi values are same. With phi value only it will changes, right? Then you will get this 14.5. Here this is 25 and this is 14.5, 14.9 total. 14, 10.1 plus 4.8, 14.9. How we can find out the, this is the pressure, okay? We are talking kilonewton per meter square. How to find out the force? Same thing, half into base into height. If it is a triangle, if the rectangular breadth into width, you take it where it will act h by 3, where it will act b by 2, and so on. Same thing. P1 half into base into height. P2 is 2.5 into 10.51. Total is 77. Then PZ taking the moment about the C, you will get this one and you will get 1.44. That means it will act, suppose this is the wall, it will act, this is the resultant, I would say, okay, at a height of 1.44 meter. This is the resultant of all the triangles and rectangle. Resultant. Understood? So like that, generally we will find out all these things. Now next problem, what it is given, same thing, all these things, only K value change. Determine the active earth pressure on the wall shown in the figure. That means where you find this formula in Rankine's theory, where I is given 15. Okay, so let us check the same thing it is given. Same thing it is given. Okay, so when I is given, previously we assumed this one horizontal. Now this 15 degrees is given. Then how to find out this one? We know these formulas. Okay, we have derived it, half into gamma h square. Half you know Ka. How we find out the Ka? We'll find out the Ka from this one. Which depends on the phi and the I value. So here the phi value is given, gamma value is given, height of the wall is given. Then when you find out, okay, you will get here only one triangle. That's why it will be h by 3. What is h? 4 by 3 it will act. Since it is inclined, it will act inclined. Okay. Now interesting is, if you recall, if you have this, these are all the cohesionless soil. Okay. Now I will focus on the cohesive soil. Suppose if you have phi term also in this case. This is what the tension crack will come into be. Very, very interesting. Okay. So let us look at this problem now. What it is given. Determine the stresses at the top and the bottom. Both it is asked of a cut shown in here. Okay. Here C term also extra. C equal 20 is given. In the previous example, they have not given C value. Only phi value is given. Okay. When C values are given, however, this one will changes. This extra term will come, right? This is vertical. This is vertical, gamma z vertical multiplied with Ka makes horizontal. If you deduct 2c minus root Ka or 2c dash, you will get the active earth pressure in C5 soil, where cohesion also there, phi also there. And it is also determine the maximum depth of potential crack and the maximum depth of unsupported excavation. Already we have seen the last class only. Okay, you recall this formula? Okay, fine. So here now what we have to do, 4-meter wall is there. So here there may be wall, okay. 4-meter, phi value given, C value given, gamma value given. First thing what we have to do is find out the K naught, Ka, sorry, for active earth pressure. See, if you see this kind of problem, what you have to do is first, without thinking anything, you just first find out the Ka or K naught or Kp. What is K naught here? 1 minus sin phi by 1 plus sin phi. Okay. What is the value? You will get this one, you will get it. What is the vertical stress? Now, here, as I said, okay, the the horizontal pressure or active earth pressure at the surface for clay soil would be negative. So that's why, suppose this is a point or 0 point, if you observe at the A, when you do it, okay, Ka, gamma z we don't know, okay, some z only we are using, minus 2c root Ka, will get this one. When you substitute z equals 0, you will get this negative 32.5 at the top. When you substitute z equal 4 total, you will get this value, positive. This is negative and this is positive. It means somewhere it would be 0, right? Negative and the positive. Where it would be 0, nothing but our tension crack. Where is that? Potential tension crack. We have seen this one. You make it 0. This, when you make this term is 0 and find out z, you will get this z. 2c by gamma, as I said, is very important for gate. Okay, 2c gamma, 2c by gamma root Ka. 2 we know, c we know. Okay, gamma we know, root K we know. Nothing but the 2.745. 2.745. This is the tension crack. That means, look at here. So it will occur tension crack at deeper depth, more than half of the depth. There may be chances of tension crack, potential tension crack. So what is the maximum depth unsupported excavation? That means up to what depth we can excavate without unsupport or lateral. This one, suppose I want to excavate like this. Okay, so this is the soil. Okay, so here 2.75, 2 times this 2.75. That's what we have seen, right? HC is equal to ZC. 2 times. So up to that depth we can excavate without lateral support. That means this diagram will go like this. Up here. That means actually Wall is 4 meter is given, but it is coming up 5.4. That means up to this depth we can excavate with. After that, what we have to do is we have to provide some lateral support to this support. Soil may fail. Understand? So that's what the unsupported excavation and the tension crack. This is very important. Very important. Okay. So likewise, we can keep on solving this kind of problem. Okay, whether it makes CEPC soil or sea soil and so on. Okay, so same thing. After, so here also you just draw the pressure diagram if you are okay with the effective stress chapter. Similar problem we can solve. All the problem we can solve. That's what I have given you the assignment problem. So we can go keep on going this problem. See here what is asked the next problem. Height is given. Determine ranking earth pressure before formation of the tension crack, after formation of the tension crack. Okay, so same formula we use it. Let me check it. What is that? So before formation of tension crack and after formation of tension crack, you can do it. Before formation of tension crack means this one, this part. After formation, we will consider only this part. Tension crack is formed and this would be 0. Okay, and that's what it is done. You just go through it. Okay, go through it. So it all these problems are very simple and you can easily understand. First try to understand this particular chapter. It's very important. So with that, anyway, I will upload this one. With that, I will stop today so that